All right. Good morning again, Honors Algebra 2. Our notes for today. We're going to be going through our second section in Unit 2, which is all about using graphs and tables to solve linear systems. So, first off, let's talk about what a system of equations is. As a definition, it is two or more equations with two or more variables whose solution can be written as an ordered pair if it has a solution. And we'll talk about if it doesn't have a solution or if it has an infinite number of solutions, how that will be written a little differently. So just as a reminder, hopefully from Algebra 1 you remember this. If not, here's where we'll go over it. But a line is a set of points that are solutions to a linear equation. In other words, every single point on a line, if you were to put it in, would make your equation true. That's different when you look at a system. So the solution of a system of equations is a point of intersection that satisfies each equation. In other words, it's that one point that works for both. So in these first couple examples, we're going to check to make sure that we actually have some solutions. And for whatever reason, I think the negatives didn't print out here. So let's go ahead and add those in just to be safe. There should be a negative x minus 2y here equals negative 6, and then 8x minus 6y. I think those were where all the negatives were missing. So it says use substitution to determine if the given ordered pair is an element of the solution set for the system of equations. So what we'll do is we'll take our 2, 4 and we'll put it in for x and y. Keep in mind for a point, x comes first, y comes second, so 2 is x, 4 is y. So in our first equation we would have 2 minus 2 multiplied by 4 is equal to negative 6. For our second solution we'd have 2 multiplied by 2 plus 4, is that equal to 8? So let's check and see. 2 minus 2 multiplied by 4, which 2 multiplied by 4 is 8. 2 minus 8 is in fact negative 6. So we're good there. Let's see, second one, 2 multiplied by 2 is 4. 4 plus 4 is 8. 8 does equal 8, so we're good there. So what we can say is that 2, 4 is in fact a solution. All right, so why don't you go ahead and try the second one. If you want to pause the video, I'll go ahead and work through it here in just a second. But I'll give you a chance to pause the video in case you want to try this one on your own. All right, so I'm going to do basically the same thing with this one. I say 2 multiplied by 3 plus 3 multiplied by 2. Is that in fact equal to 12? Question mark. And let's see, this becomes 6 plus 6. Is that equal to 12? And 6 plus 6 is 12. 12 equals 12, so we're good. Let's try second equation now. So 8 multiplied by 3 minus 6 multiplied by 2. Is that in fact equal to 24? Question mark. And let's see, 8 multiplied by 3 is 24, minus 6 multiplied by 2 is 12. Is 24 minus 12 equal to 24? The answer is no. So what we'll say instead is that 3, 2 is not a solution. And notice we're not saying that it has no solution. We're just saying that 3, 2 is not the solution. So you can still have a solution, we just don't know that it's 3, 2. All right. As far as how we classify linear systems, there are 3 main types. If you think about what types of lines you see here in this first one, these are parallel lines. So when you think about parallel lines, remember the solution is where the 2 lines will intersect. Because parallel lines will not intersect, you have no solution. So you would actually write that. For the second 2, where they are intersecting, notice that they are intersecting at a single point. So you get one single solution. And then you just write out whatever that solution is here, whatever this point is. For the last one, there actually are 2 lines here. Now you can only see one because they're right on top of one another. They are the same line. In which case, really they're intersecting here, and they're intersecting here, and they're intersecting here, and here, and here, and here. And they're intersecting an infinite number of times. And so you've got an infinite number of solutions, and so that's what you would write. All right. Moving along here, let's actually look at how we're going to solve. So to solve a system by graphing, here's kind of your step-by-step. First thing, rewrite each equation in slope-intercept form if necessary. In other words, what we're talking about there, get y by itself. Second thing, graph each line either by hand or with a calculator. We're going to do it by hand first, and then I'll show you how to do it with the graphing calculator second. We're going to find the intersection point, and so the way to do that on a calculator, second calc intersect, and press enter. We're going to check your solution. I'm not going to really show that every single time, but it is a good thing to make sure you do. And then in step 5, we're going to talk about the type of system and the number of solutions. Once again, it looks like there's a couple negatives missing in some places here. Let's go ahead and add those in. For number 3, 2x minus 3 and x minus 1. For number 4, 2 plus y should be equal to negative 3x. Down here in numbers 5 and 6, it looks like you've got y equals negative 2x plus 1. 4x plus 2y equals negative 8. For number 6, y equals negative 1 half x. And 4y equals negative 2x plus 8. Okay, so let's go ahead and look at some graphing here. Again, I like to color code these. So you'll see me use blue for my first equation and red for my second equation. For the first one, and this is a good review of how to graph a line, since it might have been a while. Keep in mind your value, which is by itself, this constant value, is your y-intercept. So our first line has a y-intercept at negative 3. The slope, being your rise over run, or your change in y over your change in x, as a fraction, you could write it as 2 over 1, meaning go up 2 and to the right 1, up 2 to the right 1, up 2 to the right 1. And if you want to go the opposite direction, you go down 2 to the left 1, down 2 to the left 1, and then draw as straight of a line as you can through those points. Okay. Second one here, we're going to graph y equals x minus 1. So this time, y-intercept is negative 1. And for our slope, we have a 1 in front of x. So 1 over 1 would be our change in y over change in x. So up 1 over 1, up 1 over 1, up 1 over 1. Continuing to do that, and again, drawing a straight line through those as best you can. Here would be our graph. So then what you look for is where they intersect, which it looks like is at this point. Looks like it's at 2, 1. But then here's where it's kind of nice to check, especially if your lines aren't the straightest. And because I don't have, obviously, a ruler to use on the screen, really can't draw a perfectly straight line. So I'm going to go ahead and check this first time just to make sure that we're good. So 2 multiplied by 2 minus 3 should be equal to our y value of 1. And 4 minus 3 is 1, so it works for the first equation. Second equation, 2 minus 1 should be equal to 1, and it is. So it looks like this is, in fact, our solution. So these would be intersecting lines, which means that they have one solution, and that one solution is here at 2, 1. All right. Second one we're going to look at. And notice this time we don't have y by itself. So for the first equation, we're going to have to move 3x over. We're going to have to subtract 3x from each side. For the second one, we're going to have to subtract, it looks like, 2 from each side. So I'm going to go ahead and get those equations straightened up over here. For the first one, we subtracted 3x, so we got y by itself is equal to, I'm going to put the negative 3x first, and then this positive 3, which becomes a plus 3 after it. For the second one here, it looks like we were getting rid of the 2 on each side. So when we did that, we got y by itself is equal to, in this case, I'm going to leave the negative 3x at the very front of the right side and put the minus 2 after it. Now before you graph, here's where a little bit of review. Remember, if you have the same slope, the same number in front of x, that you can already tell that these are going to be parallel lines, meaning that they should have no solution. So to graph those, I'm going to go ahead and use a graphing calculator for this one, since we already know they have no solution. But this would also be a good chance for you to practice, especially if this first one didn't make sense, kind of how to graph them. But I'm going to go ahead, put those in graphing calculator. Notice I still have the piecewise graphs in there from earlier. If you have not already watched the video, it is kind of nice to be able to know how to graph piecewise functions using graphing calculator, but not something that's required, especially since you should be able to do it by hand. So let's see, our two equations were, let's see here, negative 3x plus 3 and negative 3x minus 2. So negative 3x plus 3 3x minus 2. And so if it's your first time graphing today on this calculator, or if you've been using it before, I always like to hit zoom 6 to make sure that I'm in a standard viewing window. So here's our first line, here's our second line, and just like we thought, they are parallel lines, not going to intersect. So we're going to say that there is no solution, and that's what we've got right here. Okay, next one. And this would be a good one to try on your own. So if you want to pause the video, you can go ahead and do that. This will be one that I'm going to go ahead and graph by hand. So I'm going to go ahead and start graphing the first one since it's already got y by itself. It looks like I'm at +1 to start off with, and then my slope is down to the right 1, since -2/1 would be my rise over run, or my change in y over my change in x. I'm going to do that for a few points going to the right, and then go the opposite direction up to the left 1. Do that a couple times going to the left. And again, I'm going to try to draw as straight of a line as I can through all those points here. There it is for the first equation. All right, second one, need to get y by itself. So start with getting rid of the 4x from each side. Again, when I do that, let's see, now I've got 2y equals -4x minus 8. Then let's get y by itself, so let's divide everywhere by 2. That gets me y is equal to -4 divided by 2 is -2x. -8 divided by 2 is, it looks like, -4. So -2x minus 4. Maybe at this point you're already seeing what type of line it's going to be. I'm going to go ahead and graph these though, just so I can show you. So we're going down 2 and to the right 1, or up 2 and to the left 1. And notice that once again we're going to have a couple of parallel lines. And as soon as you saw the slope, you could probably tell that was going to happen. So make sure that you write that they are parallel and that there is no solution. Okay. Last one here, and this will be the last one for today because we'll start talking about algebraic methods and how to use those on Monday's class. So, that being said, let's go ahead and look at number 6. And I'm going to choose to use a graphing calculator for this one. So I should only have to worry about one equation. Let's just go ahead and divide that whole second equation by the number 4. That way we get y by itself. Simplifying as we go, so -1/2 x plus 2. And notice what's happened with our equations. Notice that they are exactly the same. So using what we learned from before, this would be where we'd write that there are an infinite number of solutions. So I'll show you what that looks like on the graph. It's really not going to be anything spectacular. It's really just going to be the same thing twice. It will give me a chance to show some of you, though, how to get fractions on your calculator. So if you're someone that has a newer TI-84, if you hit alpha y equals, and then choose the n over d option, that will actually let you type fractions in kind of fraction form. For those that don't have fractions that you can use, all you'd have to do differently is put in the negative and then parentheses type 1 divided by 2. It works the exact same, and I'll show you that it is the same because it should be the same graph. Let's take a look here. We've got -1/2, and then our rest of our equation is the x plus 2. So we type that in here. And then same thing down for our second equation. Type in the x plus 2 here. And then when we graph, and it is kind of cool to see, especially if you watch mine with the colors and if you have a color graphing calculator, because what you'll see is the first equation coming in blue here, and then the second equation will come in red right over the top of it. So you can actually see that same line getting graphed right on top. All right, guys, that is it for today. Please be sure you hop on to Big Ideas Math and get those 2 homework assignments done by Monday, and I'll see you then. Have a good weekend.